Hello everybody, welcome. In this screencast we learn how to use MPS. We'll follow the Shapes Introductory MPS tutorial so that within 2 hours we should have a language that allows us to define graphical shapes and put them on canvas, and our code will then be compiled into Java Swing application which we can run to visualize the shapes. So we'll create a language that will provide commands for drawing a circle and drawing a square on the canvas and give them some parameters on where they should be drawn and what colors they should have. And then when you run it, you'll get a runnable Java application which shows the shapes on the canvas. The purpose of this exercise is to have you implement a simple language in MPS so you can understand how MPS works and what it can do for you in more complex scenarios. So are you ready? If you want to see how a completed project looks like, you can always pick it up from the MPS samples. Since version 3.1, you'll see the Shapes sample project there. If you have an older version of MPS, then you have to download it manually from the link that the documentation points to. Here. So we'll start from the welcome screen and create a new project. We'll give it a name. We'll give a name to the new language. And we also indicate we want a sandbox solution so we can try that language right away in the same project. Okay, so now we've got an empty project which contains an empty language where there's nothing in there, and an empty solution, a sandbox solution, so a place to try our language immediately. The language that we are going to design will contain 5 language elements. It will contain a canvas to hold the whole screen. It will hold shapes, which will be an abstract concept for all graphical shapes that you could possibly draw on the canvas. We'll have 2 concrete implementations, a circle and a square, but obviously we could add more. And then we need a reference to a color, so that we can give each shape a color. And we'll start off by creating our first language concept, and that will be shape, the abstract super concept for all graphical shapes that a language can allow to specify. So now back to the language. If we go to the structure aspect where we design concepts, so this is the place where we design the abstract syntax of our language. Now you can right click on structure and pick new concept. And now on the right hand side you get an editor in which you can define the concept. So we'll give the concept a name. It's going to be shape, and we'll make it abstract because we don't want shapes to be drawn on the canvas. It's just a common super concept for all concrete shapes that will be drawn. So now here's a handy shortcut you'll need during this tutorial, and that's called Alt-Enter. So if you hit Alt-Enter, you get this little context-sensitive pop-up menu in which you can pick some of the options. In our case, we'll pick Make Abstract to make the concept abstract. Now notice the abstract word was prepended to the shape. Okay, well that's it for shape for now. Later we will add a color to shape, because all shapes have colors, no matter whether they are circles or squares or whatever. So shape is the right place to add the color, but we'll do that later. Now let's go back to structure and define a new concept. Give it a name circle. And now this one is going to extend shape. So circle is a shape. So in your language, if you define a circle, if the user types in circle, it is a kind of shape. So it can be used in the language wherever shapes are expected. Now we'll give circle an alias so that MPS can recognize that the user wants to add a circle whenever the developer, the user, types in the word circle or a part of it. And code completion will contain this word circle for entering circles. Now circle is a concrete concept. So a developer will at some point enter circle in the editor, but to fully define a circle, The developer also needs to specify its position on the canvas using the X and Y coordinates and the radius of the circle. So to specify these three numbers, we need to add three properties to circle, each to hold one of these values. So now you get to properties, you hit enter, and now you can type in X to give a name of to the first property. So it's going to be X, and the type of the value is a whole number, an integer number. So you type integer, and you may anytime you may use Control Space to complete anything that you are typing. You know, MPS provides you with a projectional editor. It's not a plain text editor, it's an editor with certain rules, and Control Space is a key shortcut for you whenever you want to complete part of a text that you type in. So remember, Control Space is your close friend when editing code in MPS. So now we have first property X. I hit enter, so I can add the property Y, and again it's an integer type of property. Well, the third one is going to be called radius, and again it's going to be integer. So again, integer and Control Space, and we have our circle ready. Now the second shape we want to use is called square. So back to the structure of the language, and we'll create a new concept called square. Again, Control Space and pick shape, because it's going to extend shape. Now the alias is going to be square, and now the properties, again hit enter, and for square we need to specify the position of its corner, upper left corner on the screen, and then the size of the square. So upper left X is the first one, again integer, upper left Y, and then, well, the third one will be size. Okay, and we've got square ready. The next concept to create is canvas. It will represent the scene, and it will hold all the shapes that should be drawn on the scene. So again, structure, new concept. It's canvas. Now it should remain base concept. It's not going to be a shape, because we don't want canvases to be put on another canvases. However, we would like to give names to canvases. For a canvas to hold a name, it needs to have a name property. But instead of adding a name property here in the properties, we'll use the iNamedConcept interface, Control Space, iNamedConcept. An iNamedConcept, if I hit Control B, I get to definition of iNamedConcept. This comes from MPS, and it already holds a property name. So by implementing this interface, our canvas gets a name property, so it can be given a name. Also, we want canvases to be roots. So true, Control Space. Being a root for a concept means that you can put them in models in the root level. So you can put them right here. So they could form roots of your ASTs. Like in Java, you can put Java files directly in packages, while Java methods have to be contained within classes. So classes would be a root concept, so to say, while methods wouldn't be root concepts, because they cannot cannot be directly part of a directory structure. They need to be nested in a class, while a class can be directly put in a file system. So similarly in MPS, root concepts can be roots of AST, so they can be at the root position in a model, like in this one, while non-root concepts like circle or square have to be nested within other root concepts, like within canvases, for example. So now we have a canvas. It's a base concept, named concept, a root concept. So now we need to say that it holds shapes. So we go to the children section, hit enter, and say that each canvas has a collection of shapes. Now I hit tab to get to the next cell, Control space, and we pick shape. So all shapes, no matter whether they are circles or squares, can be part of this collection of children. And now the cardinality, control space. So there can be 0 to n shapes on a canvas. So now we'll rebuild the language. So we'll go to the shapes node. Notice the L, representing language, and we say rebuild language. So now the language will be rebuilt, so we can use it in our sandbox solution. All is fine. So we go to the sandbox model and create a new canvas. So we have a canvas, we can give it a name. So now canvas, this new canvas has a name, my drawing. Notice my drawing is also mentioned here in the list. So that's thanks to being I named concept. And now we have all the shapes that belong to that drawing listed here. So there are none at the moment, but we can add them. So when you hit enter, you get an empty cell for a shape. So control space, I can pick either circle or square. I go with circle. So I've got a circle. Now for X I might specify some value, 10. For Y I might specify 20. For radius 30. I might hit enter again. Control space, square. So we can go 100, 200, and 50. So now we are writing code in our newly designed language. What we lack, though, is a nice editor. The editor we're using here is just copying the structure of our concepts. So there's a drawing which contains shapes. We've got a shape circle and a shape square. The circle contains x, y, and radius, and square contains upper left, upper left x, upper left y, and size. But we might prefer different layout of these shapes, of this code on the screen. And that's done through editors, and we'll do it right away. Let's start with circle. So at the moment, circle uses the default editor that displays the properties listed below one another. Instead, what we would like to do is to create a circle command, and the command will take like 3 parameters, all on the same line. Back to circle concept, hit plus, and pick editor, concept editor. So now we'll create a new editor for circle. So this is a default editor for concept circle, and here we will lay out the components holding the individual properties. We will lay them out on the screen somehow. So the first thing to do, we need to create some layout manager that will manage all the visual elements on the screen. And for our purpose, the best one is the indent layout. So control space, and now search for indent layout. Here we go, indent layout. Or you might type square bracket minus, and it will create an indent layout for you. So now we've got an indent layout that will, as a manager, managing all the visual cells that will be created inside of it. So now we'll create the cells for individual properties of a circle. So for each circle, the first thing we would like to see is the word circle. So just type circle, hit enter. Now, after the word circle, we would like to specify the x coordinate. So now I type x and colon. So this is just plain text that will be displayed on the screen, and the developer will not be able to change it. And now we need the value for the x property. So hit control space and pick x in curly braces. So now this is a reference to the x property, while this x, this is just a text, random text that you decide to put on the screen so that the developer knows better what she's editing. So cursor here at the end of the X property, we hit enter, and we can add a label for the Y property, and control space the Y property itself. And now radius, label, and the radius property. And that should be enough. Now for square, we'll do pretty much the same thing. So for square, we want to have an editor. The editor will have an indent layout, so square bracket and minus. We start with square, upper left X, colon, control space upper left Y, colon, upper left Y, and size, colon, and the size property. Cool. So both shapes now have editors. We should also create an editor for the canvas itself. So canvas should have an editor. Again, indent layout. Now in that indent layout we put a text. Painting, then we put a name for the canvas. And now we would like to organize all the shapes vertically. So hit enter, and now select vertical layout. So now we'll have a vertical collection of shapes. Shapes is a child collection of canvas, so we'll have it in the pop-up menu. So we'll see all the shapes listed one below another. And the last thing to do is to put the whole collection on a new line. So below the painting and name text. So on the collection you hit Alt Enter and specify on a new line. So your editor should be transformed slightly, and that should be it. So again, we can try how our language looks like when used. So right click on shapes, hit rebuild, and the language gets rebuilt, including the new editors. So now we can use the new editors when defining our canvas. My drawing. So notice the code has been reorganized to use our new editors. So here is the painting with its name, which we can edit. Here's a circle with its properties, which we can change to other values. When we hit enter, we get a new line, and we can specify the values. Now what I don't like, well, we used upper left X, which is sort of clumsy. So we can go back to square and rename this property to plain X. I mean the property is still upper left X, but the label that we use should say just X and Y. I think it's more intuitive. And we use this notation in the tutorial, so let's be consistent. So now when we rebuild the language, now we get a slightly shorter notation, which is perfect. Well, I think we already accomplished quite a lot. We've got both abstract and concrete syntax for our language, so we can edit code in our language in the editor. Now there's one missing piece in the syntax of the language that we still haven't implemented, and it is the support for colors of shapes. So this is going to be slightly more advanced, so let's jump on it. I'm pretty sure you'll make it. So what we'll try to do is we'll add colors to all shapes. And a color, for example, for a circle, when we specify a color, we want to select from a list of colors that are available, in our case in Java, because we'll be using Java as a platform to run our applications. So we'll pick from the Java colors for each shape. Now to do that we need a new concept, a concept that will represent a reference to a color in the code. So hit new concept, we'll call it color reference. It's going to be a base concept. It doesn't need to implement anything, definitely won't be a root concept, doesn't need an alias. But what it needs is a reference. So we go to the third section, the one we haven't touched yet, which contains all references going across the model and pointing to some other parts of your code. So I hit enter and I say, well, I've got a reference, I'll give it a name color, and it will go to a static field declaration. Why static field declaration? Well, if I open the color class, if I open the color class in Java, now you see that there are predefined color constants in the color class which represent various colors, and these are technically, if I select one and open it in the inspector, I see they are static field declarations, right? It's mentioned right up here. So I want to reference from my code to one of these. So color will reference the static field declaration and always exactly one. So each color reference points to exactly one static field declaration, and later on we'll add a constraint that will make sure it only points to static field declarations of the color class. So for now we've got the concept defined. Now we need an editor. So how this color reference will look on the screen? Well, we'll just put the color, so the static field declaration that we point to, and we'll take its name. So each color in the color has a name. So basically the name here. So this is what will show up in the editor, the name of the static field declaration. So this text, the name of the static field. So now we need a constraint. So we need to specify where the static field declaration may sit. So we'll create new constraints. In our case, it's going to be a reference constraint for the color reference. So control space, you pick color, and now we pick the reference scope. So here's a function in which we specify the list of allowed targets for the reference. So the list of allowed color constants that the reference can point to. Now in order to be able to type code in here, we need to import certain models. So now we'll do some exercise to import all the models in our language. Alright, so three places where we need to import models. First, the language itself. You click on it in the project view and hit Alt Enter. Now you get this dialog with properties for the language. We'll go to dependencies and we'll add base language, JetBrains MPS base language, and JetBrains MPS kernel. So our language now depends on these two, and also, well, additionally, it extends base language. Okay? Then the constraints of our language. Again, you click on that node, hit Alt Enter, and we need to add the scope language, JetBrains MPS scope, and the Java AWT package which holds the color class, so we can refer to the color class. Well, and third and last, we'll go to the solution to prepare for the future when we'll be using that language. We will also need to support Java in the solution. So again, hit Alt-Enter on the solution, and in the dependencies we'll add Java JDK. This is the one. And now all dependencies should be set properly. Perfect. So now we just need to type a bit of code that will return an instance of scope interface, and that instance will hold all the colors from all the color constants from the color class. Well, okay, so what we'll do, just type new list scope, control space to complete. So now we've got a new instance of list scope, an anonymous inner class with empty implementation of the getName method, which we now need to provide code for. Well, the code will return a name of the color. So we take the child, which is the color that we're given. We need to cast it to static field declaration, control space, dot, and now we take the name. So we implemented the abstract method of list scope, but list scope, if you hit Control P or Command P on Mac, you get the list of expected parameters. List scope expects a sequence of nodes. So we need to give it a sequence of nodes, and it will build a scope around them. So that's the purpose of list scope. And when the code completion dialog is invoked, it will check the getName method to get proper strings to feed into the code completion dialog. So what we put in here is basically all static field declarations in the color class. So first we need to get the node representing the color class in MPS. So we type node, control space, and the first option is the one. So we take node that represents the color class from the Java AWT package. So now we have the color class, and it has a static fields method. So a method that returns all static fields of that class. So we call that method, and that's it. So this method gives us all static fields from the color class, and we'll populate a list scope with them and return their name if we are queried for the name of the nodes. Well, and that's it. So having defined the reference to colors, we can use that reference in our shapes so that they can have colors. Since all shapes have color, we won't go to circle or square, but we'll go to the common super concept shape. And the shape will have a child which will be a color reference. So we'll give that child a name, color, and it will be a color reference, exactly one. Now we'll create an editor. Since we would like to inherit an editor for color into all shapes, we won't create a new editor for shape. Shape is an abstract concept after all, so it doesn't need an editor. But we'll create an editor component, a reusable editor element that subconcepts can reuse. So a new editor component, we give it a name so we can easily identify it. And here we'll define the reusable editor component. So just like for circle and square, we use the indent layout square bracket minus to manage components in the editor component. Now we provide a text label indicating what we are actually editing in the editor. So color as a constant cell. Then hit enter, control space, and we pick color, which is a reference to the color constant. Good. So that's our editor component. Now we embed that editor component in circle and square. So when you go to circle and you pick the editor for circle, you can go at the very end, hit enter, and then control space, and we just pick the component shape color. Here we go. So that's the shape color, that's this editor component. We're just embedding it in the editor for the circle. And we can do the same for square. So editor for square, enter, control space, shape color. Good, that should be it. Now we should be able to rebuild our language and test it right away. So my drawing, you see colors, they are not defined now, they're new, but we have a placeholder for color. So we can hit control space and pick a color. For our language to be of any use, we now need to provide a generator that will translate the code, as you see it on the screen, into Java. Java that will show a JFrame on the screen and draw the shapes so that they reflect the properties that you set in your language. So for this we need to go to the generator, open the main mapping configuration and start editing here. So this is a generator aspect. In here we have a generator model, and in that generator model currently we only have one root node, and that's a mapping configuration called main, in which we will specify the rules for the generator. The first rule we'll add is a root mapping rule. So you hit enter, now you hit control space, pick canvas, and this root mapping rule will specify how a canvas gets mapped into a Java class. So for each canvas we get a visual JFrame extending Java class. So you hit Alt Enter here and pick new root template and choose class as the target root concept. Now we have a map canvas template created which defines an empty class, and now we fill it with functionality. So now we specified how canvas should be translated into a Java class. I mean, we prepared a skeleton for how canvas should be translated into a Java class. And then we'll specify how individual shapes like circle or shape get translated into Java code that draws the particular shape on the canvas. And the last thing we'll have to do is to translate color reference into some Java code that will point to the real Java color in Java code. But let's proceed gradually. So we'll start with this Java class template and start adding code here. Before doing that, we need to specify dependencies for the generator. So first, for the generator module, you hit Alt Enter, you get the configuration dialog, and in the dependencies we'll add Java, JDK. So we're done here. And now for the model, you hit Alt Enter, and we'll add Java AWT, and we'll add Java X swing. Good, we're all set. Now, with the dependencies set, we are ready to modify the template for the generated Java class. So for each canvas we get a generated Java class, and that class, when run, will draw a JFrame on the screen and then draw all the individual shapes on it. For those who know Java, this will be a pretty easy exercise. For those who don't, please follow me step by step. I'm sure you will get through this easily as well. So the first thing, our class needs to extend JFrame. So you type extends, then control space, now JFrame. Notice capital J, capital F, lower R, control space, we pick JFrame. So now our class extends JFrame, so it can be drawn as a frame on the screen. Now the class should be given a name. So you click on the name of the class. We don't want the generated class to be map_canvas. We want to give it a different name. So now we'll need the Alt-Enter functionality to insert generator macros into the template. And these macros will be used to insert values from the input model, from the canvas that the user created. So to insert these values into the generated class. So the template will hold macros as placeholders for values from the input model. Alt-Enter. And now you pick property macro, because we'll be creating a property macro. Hit Enter. Now the inspector window opened at the bottom. So this is a place where you specify details for the elements that you select up in the editor. So if you select the macro, now close to the $sign, now you are allowed to edit the code behind that macro. This macro should insert a string into the generated class that will represent the name of that class. So I suggest we gave that generated class a name of the canvas, this name. So node.name, node, Control Alt T. Node holds canvas. So node represents canvas because this is a template that's translating canvas into a Java class. So wherever you refer to node in macros, node is an instance of a canvas. And each canvas has a name. Canvases, we gave them names. My drawing. And this particular canvas is called my drawing. So the generated class will be called my drawing. Well, we could add some extra stuff. We could concatenate this string with some extra value. So as long as the string remains a valid Java class name, you can use it in the macro. Alright, so now we have a class, and the class has a name. So let's has a name set. So maybe we could try that. So I rebuild the language. And now we go to drawing, and now for the first time we can try the preview generated text functionality. So now we'll see what code gets generated out of this painting. And here we go. So it's a class called my drawing. However impressive this may seem, we need to go further. We need to give that class a bit more functionality so that it really shows up and draws the shapes. So back to the template. And now we'll need to add some code to it. First, we want that class to be runnable, so that when you type Java and class name, it will run. So it needs a public static void main method. In MPS, you just type public static void main as 4 characters, PSVM, and you get the main method for free. Alternatively, you can just type it by hand, but this is much shorter. Now, inside the main method, we need to create a new instance of our class. So you can go map _ control space canvas. Now we give it a name, canvas equals new map _ control space map canvas. So now we created a new instance on that of this class. Whatever the final name of that class is, now we are effectively manipulating an instance of that class. So we'll create an instance of that class. Now that class, when created, needs to initialize visual components, so it shows something on the screen. And for that we'll create a new instance method in that class. So you may type method and hit control space. Now you get a skeleton for a method. We give it a name, initialize. So that's a method to initialize the component. Now we should call that initialize method from main. So go back here and call canvas dot initialize. Control space again. Now we also need a field to hold the panel that will contain all the shapes drawn. You know, in Swing you need a component that you could draw on, and we'll use a panel for that. So you type field, the type is jPanel, control space, jPanel. We can give it a name, panel, equals, new, space, jPanel, control space. And now hit curly brace, left curly brace. This will turn this field declaration into an instantiation of an anonymous in a class. So left curly brace will do this little trick so that now you get jPanel where you can override some of its original functionality. And we'll override the paint component method. So hit Ctrl O to override, Ctrl O, and now you can start typing paint component. When you get that method selected in the list, paint component, hit enter. So now we are overriding the paint component method of jPanel. Be sure the method is called paint component, not paint components, and be sure it is nested inside the anonymous inner class definition. If you have that, now you just type SOUT for system out print line and type some text in there. So that's a placeholder which we will replace with the methods that will draw individual shapes. Okay, the last piece of code that we need to type in is the initialize method, where we need to set things correctly so that they show up on the screen. So now please follow what I type. So this dot set title, control space, and title. So that's a title for the frame. Each frame has some title at the top. So this is how we set it. Now this dot set default close operation to define what should happen when the user closes that window. We want the application to terminate. So we go J frame control space static access exit on close. Then we add a panel. So this add component, and the component is panel. That's the field we define at the top, right? This panel. So now we're adding the panel to the frame. This. So we're adding the panel to this frame. Also, since panel has no default size, we need to set a default or preferred size of the panel so that the panel occupies some real estate on the screen when it shows up. So panel dot set preferred size, and we define a new object, new dimension object. New dimension will specify two integers, 500, 500. So that's the size. And now the frame needs to be packed, and it needs to be made visible. Set visible true. Alright, well that should be it. So let's see what happens when we rebuild the language. And again, have a look at what my drawing gets generated into. So now this is the class that gets generated for our drawing. So it's a class, my drawing, which extends JFrame, and it contains the code that we specified. So there's a public static void main method to create an instance of my drawing here and to initialize it. The initialize method will set all the properties correctly, and we've got a panel that has the paint component method redefined. But still the class is not customized very much. Besides the name of the class, there's no customization, so it won't draw any of our shapes that we define. They are not reflected in the code yet. So that's what we need to do next. Back to the template. So far we've customized the name of the class. We might also decide to customize the title so that it reflects the actual name of the drawing. So now we select title, so we go Control up or Command up on Mac to select title, just the word, not more, just the title. Hit Alt Enter and now pick property macro. And again we'll put in node dot name. So the name of the canvas will be reflected in the title of the frame. And again we could make the function return any arbitrary string. That would make sense. By the way, I use Alt 2 to show and hide the inspector panel. Okay, so this was property macro, and now we will use node macros to transform the code here into code that will paint the shapes on the panel. So again, you come to this line and hit Control up or Command up to select the whole line, including the semicolon. You hit Alt Enter and pick loop. Loop macro over node.shapes. Well, that's what we want. If you don't have that option, pick node macro and then type loop in there. And now in the inspector window we need to type node.shapes. Effectively what this code does, it will loop through all the shapes that the canvas contains. And for each of these shapes it will replicate the node here. So in our case system out print line draw here. Well, we can try that. So I rebuild quickly. And when we go to my drawing and preview generated text, we see draw here, draw here, draw here, repeated 3 times, because we've got 3 shapes in our language. But obviously we don't want to get system out print line in the output. That's not our goal. We want each of these system out print lines to be replaced by code that will draw the shape on the screen. And to replace them, again, use Control up or Command up to select the whole statement, including the semicolon. Now hit Alt Enter and pick node macro. We'll use the copy source macro that will take the current node and replace whatever is in here. So this is throwaway code. This will be replaced by the current node that we are looping over. So this is enough. We don't need to specify anything in the inspector in MPS 3.1. In the previous versions of MPS in 3.0, you would have to type node here. You would have to specify the node explicitly. 3.1 doesn't require that. So you can just leave that empty. Current source node is the node that we are looping over. The current shape. This is nice, but the current shape, meaning a circle or square, they're not valid Java statements. So they can't really be a replacement for system out print line. So we need to define a rule that will translate shapes like circle or square into valid Java code. So we leave the template behind and go back to the mapping configuration and create a new rule, a reduction rule this time. A reduction rule that will, when I hit Control Space, that will reduce circle to some Java code. So Alt Enter, new template. And we have a reduce circle template defined. Here we go, here it is. You can either open it by clicking in the left panel or by Control clicking or Control B in the editor. Control B, here we are. So this is the template, which is transforming circle into some Java stuff. Well, the Java stuff that gets generated will be specified here. And we'll use block statement. If you know Java, you know block statements are statements nested within curly braces. So you type block statement, Control Space, and now you get curly braces. That may contain Java code. Now you can type, Java code that you wish to be part of the template. Well, the first thing, if we look back into the template to see the context, so the code that we are just going to generate will be placed into this paint component method. The paint component method gives us the graphics parameter. And we need the graphics parameter, the object, to draw something, to draw anything in Swing. So we need to get hold of this graphics inside the code that we generate. So when we go back to the circle shape, we will create a local variable of type graphics called control space graphics, and we just set it to null. So this is to define the context, so that now within the code that we specify below, we know there's some graphics variable around which we can use. In the template here it's going to be graphics, but after generation it will be the graphics parameter. So back to here. Now again a curly brace to create another nested block statement, and now you select this by Control or Command up, just the nested block statement, and hit Alt Enter. We'll make this a template fragment. So now we are really saying that the important part here is the stuff here within the curly braces. This is a template fragment, so this is the piece that will replace the system out print line here. So this will go away, and this will be placed instead, this block statement, which currently is empty, but obviously it won't remain empty, because what we'll do here, we'll call the graphics local variable, and we call set color on it. Set color, and to some dummy color, we'll pick red for now. You probably know already, well, this is just a placeholder for the real color that we'll set at some point. So we set the color to red, and then we'll call draw oval with some, again, dummy values in there, 10, 10, and we'll use macros to provide the real values instead of these dummy colors and positions and sizes. Okay, so let's do it. So the first value 10 is selected, hit Alt Enter, and pick property macro node X. So we'll use property macro because we'll replace this value 10 with a property of the current node with the property X. So you could either hit node.x or you could just pick add property macro and now type node.x. Now for the second value we'll pick Y. For the third value we'll pick radius, and for the fourth value we should also provide the radius, because we are not drawing an ellipse but a circle, so sizes in both directions are identical, so we'll use radius for both. Now with color it is slightly different. You select red, hit Alt Enter, and now pick reference macro. So now we're changing the reference, because this red is a static field reference, as we can see down here in the inspector window, and we're replacing that reference to refer to the real color that the shape defines, because each shape has a color reference, so we need now to use the reference hidden inside color reference, which is called color. That's a reference to a static field declaration, and we need this reference, and we need this reference to point to that declaration instead. So we use reference macro, in which we say node, which is a circle, dot color, which is a color reference, and now from the color reference we get the color, well, the static field declaration representing a color, and this is it. Okay, so now we need to do the same thing for square. So back to main configuration, and create a new entry in the reduction rules for square. Notice we only need to do reduction rules for concrete concepts, not for shape. Shape is an abstract concept, so there will be no concrete instances of shape. So we don't have to have reduction rules for those. Alt-Enter, new template, reduce square. Here we go. So it will reduce square. Now we'll create a context, block statement, control space, graphics, control space, graphics equals null, block statement by curly brace and control space, graphics dot set color dot red, and graphics dot draw rectangle, control space, 10 10 10 10, and now control or command up to select the nested block statement, alt enter, and create template fragment. So this is the place, this is the piece of code that will replace the system out print line here for squares, if it is a square, if we're looping through a shape and the shape is a square. So now again we need to set to use property macros to set the values right. So the first one is upper left X, the second one is upper left Y, then we have node size and node size, and we need a reference macro here. There will go null.color.color. So now we rebuild the language. Notice I always rebuild the whole language, although we could just rebuild the generator because that's the only part of the language that gets modified now. But I want to keep it simple for you. So now we preview. Now when you preview the generated text, now we get Java, which should draw properly the shape. So now notice that for each shape we get a couple of set color command and then draw command. So we have 3 pairs here, and they set the colors and properties as we specify them in the language, so it looks like that this is going to be right. Good, so we can generate the code. It might also be worthwhile to be able to run the code right in MPS. Well, to do that, we only need to indicate to MPS that drawings or canvases are runnable. So we need to say canvas, the concept, can be run. And for that it needs to implement the iMain class interface. The interface comes from a language that we need to import. So select shapes, hit Alt Enter, and in dependencies now add JetBrains MPS execution util language and mark it as being extended. So now we have that language added, and so we can add an extra interface to the implements section of our canvas concept, iMain class control space. So this interface being implemented indicates to MPS that the concept is runnable. So I can rebuild the language. And now when I rebuild my sandbox, I'm able to run canvases. So now when I right click it, at the bottom I see run node, which will effectively generate code and run it in Java, so I get running in a Java application. Well, and that's it. I hope you learned something new in this tutorial, and now you're in a good position to try something more advanced. Thanks for watching. Goodbye.